So in this video, we're going to take a look at service workers and what they mean for IPFS on the web and how you can use them, looking at some of the solutions that we've built at Interplanetary Shipyard. So the way that we're going to structure this is we're going to take a quick look at what they are. We're then going to see why they're useful for IPFS. And then we're going to dive into some of the solutions that we've built and how they work. So what are service workers? Well, service workers are a web API that allows you to install a piece of JavaScript code that acts like a proxy. What do we mean by that? It sort of sits between your main application and all of the JavaScript code that you have and all of the outgoing requests that you have to the network. And what you can do inside a service worker is you can intercept requests, you can then load them up from cache, or you can persist responses to cache. And you can do all of this using just standard web APIs. Now, of course, this was initially conceived in order to build offline first, what is now commonly referred to as local first, but that's a bit of a murky term. And do all sorts of things. You can also do what is known as like background sync and push notifications. So now even on iOS and Android, you can sort of register these subscriptions, and then you can actually push notifications to mobile devices. So it's quite a useful abstraction, and yet it tends to be quite complex depending on what you're trying to do. This is why we made this video, to make it easier. So let's dive into what this means for IPFS. IPFS, as you may know, is all about immutability. Not only, but content addressing relies on immutability, which is to say that the address, the SID, has a hash. That hash usually refers either to a file or a directory or just some structured data like DAG.json or DAG.cbor. But the key point is that a SID is immutable in the sense that if any of the data changes, the SID changes. So why is that useful? Well, immutable data tends to be very cacheable. You don't have to worry about it changing, which means you can store it in cache and then load it up from cache. This is why once you encode a static website with IPFS, or more specifically with UnixFS, you can sort of get an offline browsing experience for that, which is really nice for anything that is deployed to IPFS. Okay, so this is why it's useful for IPFS on a very high level, but more concretely, this is useful because we can use the service worker in order to intercept network requests to something like a trusted gateway, like IPFS.io, and basically use Helia in order to handle the retrieval inside a service worker. And you might be familiar with this because we've been talking a lot about the service worker gateway and how it essentially replaces traditional centralized gateways like IPFS.io. So how do they work? Well, the key idea is that you install a service worker gateway, and inside that service worker gateway, we use this Helia verified fetch library. What's unique about Helia verified fetch is that it's modeled like the fetch API, in the sense that it accepts a SID as input. You can also pass it a gateway URL and it will just infer the SID. But the key idea is you give it a SID and it does all of the IPFS magic of finding providers, connecting to those providers, fetching the blocks, and then reconstructing that into a single binary stream that is then composed into a response object. So just like the fetch API returns you a response object, verified fetch also returns you a response object, with the difference, obviously, that it's doing all of this IPFS magic and verifying hashes. Why is this cool? Because you get resilience. If you've hard-coded a gateway into your application, then that gateway might go down, especially if you don't control it. And so being able to do a lot of this direct retrieval or peer-to-peer retrieval inside a browser is really, really powerful. You get resilience and you get all of the caching sort of properties because it's immutable. So for a while, we've launched this service worker gateway at in-browser.link, and when you go there, you can provide it either an IPFS, like a SID, or you can do even DNS links. So you can do vitalik.eth, and it will actually resolve vitalik.eth to the latest SID. It will also redirect us, you can see in the URL bar, into an origin isolated URL that is unique for that path, that IPNS path that we're looking at. And you get the reading experience. And so, when I click a link now, instead of actually just fetching that static file from a single location, it's doing all of the sort of IPFS magic in the background in order to fetch it. And I can probably demonstrate this a bit better when I have the network tab open here. And so if I go into simplifying this, you can see that I should preserve the log so that we can actually see this. So why I support privacy. And you can see here that it's, there we go. Yes, it's making these trustless gateway and delegated IPFS. We're going to look at what all of these mean, but the key idea is it's doing all of this inside a service worker, and the beauty of it, and this is not, there's nothing special about this Vitalik's blog, except that it's just a static website. That's the only sort of requirement for it to be useful and usable inside a service worker gateway. So the rule of thumb is if you can load the site via a normal gateway, you should be able to load it also via the service worker gateway and get all of these benefits. One of which is that you can have an offline reading experience. And so now I've sort of made the developer tools, using the developer tools, the browser sort of offline. If I reload this, you can see it's all loading, and you can see it's all coming from the service worker. If I go back, it's also still functioning. Now, if I go into a post that I have not cached, it will obviously fail because the network is down. So it makes whatever you've already sort of cached inside the service worker, or whichever pages you've already visited, it makes them offline ready, local first, choose your term. And now I can obviously disable again this offline mode, and it should function again. And I think maybe having made it offline has slowed this down a little bit. Okay, well, that's happening. Okay, there we go. I think it's working. It might have actually just been that specific article, but as you can see, it's all now cached. And if I go offline again, I can go back and I can go in and into this other one, and it's all nice and offline, which is quite a powerful abstraction. Okay, so that was the service worker gateway. Now I want to talk a little bit about how it actually works. So the service worker gateway does a couple of things, but almost all of the logic that does IPFS is encapsulated inside Helia verified fetch. That library that I mentioned, you can use it also just to sort of fetch data from IPFS inside your sort of main JavaScript application. But here in this context, it's actually loading the whole site and giving you the origin isolation. And the way that verified fetch works is as follows. So verified fetch is based on Helia, which is based on libp2p. I know that's quite a mouthful. But the key idea is that when it's trying to fetch the data for a SID, it will do two things simultaneously. It'll try to fetch it from a trustless gateway. A trustless gateway is a gateway that exposes blocks with the metadata necessary to verify them. So unlike normal gateways, by the way, most gateways are also trustless gateways, but unlike normal gateways, it doesn't just return you the data, it returns you sort of like the Merkle proofs that are part of the DAG. Again, this is technical stuff. If you're in the weeds, you will know what this means. If you don't know, it just means that you can fetch the blocks for a SID, the data for a SID, in a way that allows you to verify the hashes. And in addition to that, it will also call a delegated routing HTTP API. This is an endpoint that the foundation runs as a public good. And the idea here is that instead of actually being a full DHT client, a distributed hash table client for the amino DHT, where the distributed IPFS network sort of announces, every provider announces which blocks it has, you can delegate that work to this endpoint, and this endpoint will give you providers for the SIDs. And by using this API, you actually save a lot of the network, the heavy networking part of the DHT, and just go and straight away find these providers. And of course, this is also very cacheable because it's just plain HTTP. And so this is sort of like a trade-off that we make in browsers, because browsers are very short-lived by design, and they're very sort of resource and network constrained. And so this is a way to get quick results without sort of foregoing any of the decentralization benefits and resilience and of course verifiability of IPFS. Okay, so coming back to our diagram, it makes a call to the delegated routing API, and it does that as a fallback, because if a centralized trustless gateway goes down or is blocked or just doesn't have the block that you're fetching, then it will actually try to go straight to the provider and establish it. If it finds providers, it will try to establish a direct connection and fetch those blocks directly from the peer. Now, of course, it requires also that the provider will be publicly reachable, so it can't be behind that, and that it will have the available transports that the browser can dial. Again, these are a lot of technical details that we've been obviously pushing the envelope on in so far as we're trying to make it better and more resilient and easier for nodes to be dialable from browsers. But again, this is beyond the scope of this video. I'm just sort of giving this technical background so you have it. So that was it for the service worker gateway. And the main sort of use case for this is you have a SID or you have like an IPNS name or a DNS link and you just want to view it. So this is for you, an alternative for traditional sort of IPFS IO-like gateways. This brings us to the other thing that we've been working on, which is a drop-in service worker. This one is intended for you if you're an application developer, and as part of your application, which doesn't have to be static in this instance, can be any application that might be hot linking to a central gateway like IPFS IO or one of the many others. In this instance, the idea is that you install a service worker as part of your application code, and in this service worker you intercept requests that are going to a centralized gateway, and these are very easy to detect based on the path or the host name. And if you detect those, then you intercept them and then use verified fetch to handle those. So let's first we'll take a look at a demo of what this looks like, and then we'll look at the code. So I set up this example here, and I'm just going to clear the logs and the network tab and make sure that I don't have the service worker. And what we have here is just a gallery. This is a Next.js app that is statically exported, so it's a statically generated site, not using any of the server actions or the server components, just exporting this and hosting this locally currently, but we also have a hosted version. And the key idea here is that this gallery is hot linking to IPFS.io. You can see this probably better here. So we have all of these images, and I've put sort of the alt text, the SID in it. And so we're hot linking to the IPFS IO gateway. Now, obviously, the IPFS IO gateway might go down one day. It might not continue to be subsidizing traffic, or it might get throttled. And so this is a great solution as an alternative to that. And the way it works is, I have the source code here open, is in our app, we use this hook, a custom hook that I've created, which will install the service worker. So this is how a service worker is registered using the web API, also waiting for it to be active. And let's actually open up the service worker code. So the service worker code is just 62 lines, and most of this is just setup. Now, I should also say that this is an example more so than it is a solution. It's demonstrating how you would do this, because most of the logic for this is inside verified fetch. Now, we might actually create a library that abstracts some of these details. That remains to be seen, but the key idea is that again, the install event and the activate events are, we listen to them just to make sure that this service worker lifecycle is managed properly, and that we immediately sort of activate it as soon as it's registered. These are some service worker API specific details. But the key and where the meat of this is inside the fetch handler. So every time a request goes out, for example, the gallery, which renders these image tags that have images pointing to IPFS.io, any request that goes out once the service worker is active will invoke this callback listener. And inside here, we're only doing two things. We're checking if that URL is matching the path gateway. So you can see examples of what the path gateway looks like. If it has this /IPFS, /SID, or IPNS, and a DNS link or peer ID, which is an IPNS name really. Or the alternative is the subdomain gateway. And so if you make requests to these, if you don't, then we just let the request go through and we return not doing anything. But if it is, we intercept that request and we respond with whatever comes back from verified fetch. And what verified fetch returns you is a promise that resolves to a response object, which is exactly what the respond with expects. So this is all this does. And again, everything is encapsulated inside verified fetch. Of course, you can also instantiate verified fetch yourself. So inside verified fetch, we have we export a singleton, but you can also use the create verified fetch in order to customize the configuration. If you might want to use your own gateway, or you might want to set up your own delegated routing endpoint, this will do it all for you. Okay, let's go back to the browser and see how that all comes together. And I think a good way to demonstrate this is actually, let's disable this and actually just take a broken URL. So IPFS gateway down, it's a fake URL, it doesn't exist, and this request will fail. And the reason I did this is because that will actually demonstrate how you can use this solution today without having to change all of your URIs or any hot-linked IPFS.io URLs, and be sure that as long as there are providers that are dialable from browsers, for those SIDs that you're hot linking, you will be able to fetch them directly in your application, even if the hard-coded central IPFS.io gateway goes down. So I've saved this, and let's do this. Let's open this side by side. And I will also unregister the service worker. So there's a lot of nuances that are important with regards to the life cycle of the service worker. I'm not going to go into them in this video, but the key idea is doing this skip waiting and also doing the client's claim in the activate event. And the other thing is making sure that you don't render the app until the service worker has registered. And the reason you want to wait is because on the initial load, before the service worker is installed, you want to make sure that you don't render those images or other assets that might be hot linking to IPFS.io, because they won't get caught by the service worker until it's ready. So this is why we wait for it to be ready using this ready promise read-only property that is returned, and only once it is ready, we set the state to be active, and inside the app, we then render the application. So that was the only caveat. Okay, now I'm going to reload this, and what we're going to expect to see is, let me just close for a moment the console, is we're going to see that these obviously got a 200. That's already a good sign because that URL would not work. And then what we see here is we see some failed requests, but these are not failed, they're canceled. They're canceled because the trustless gateway returned a 200 response before it was able to get a response for who are the providers for this. That was the delegated routing API call. And so if trustless gateway did not have this block or was also down, it would actually get the response from the delegated routing endpoint, and presumably there would be providers, and those providers would then be used in order to fetch the blocks from. And so it's like kind of like a fallback, so to say, for when things really break. And that's, emphasizing this sort of the resilience that you get with IPFS. Now, I don't want to belabor that point anymore. Also interesting just to see like the log events. So it's installing, that's just like the lifecycle logs that I've put here to help myself debugging, and then the interception of these requests. So that was pretty much it. You can look at this in the IP shipyard. I will put this in the video links, but you can look at this repo showing both the service worker gateways here we looked at, and also the hook to register it. This is a React hook, but again, this should work with any framework. And of course, the service worker gateway, which is in the IPFS org, and you can try it at inbrowser.link. That was it. Thank you so much for watching. If you have any questions, drop them in the comments section. And of course, please smash that subscribe button.